Okay, welcome back to the videos. We are now on section 3.3, which is solving inequalities using multiplication and division. And by the end of the section, you should be able to say, I can use multiplication and division to solve inequalities. So, a little background. First of all, here's how it works with multiplication. If we have a true inequality like we do here, where 4 is less than 8, if I were to look at positive numbers, if I looked at multiplying by a positive 2 on both sides, so this would be like the multiplication property of equality related to inequalities. So if I multiply by 2 on both sides, I would get an 8 is less than a 16. So it is still a true inequality if I multiply by 2 on both sides. If I multiply by a negative 2, start with my true inequality, 4 is less than a 8. If I multiply by a negative 2, on both sides, let's take a look at what happens now. I get a negative 2 times 4, which is negative 8. I get an 8 times a negative 2, which is...
Marley Beekler, would you please come to the attendance office for some information about your phone?
Well, I hope she finds her phone. But back here, we got negative 2 times 4, which is a negative 8. 8 times negative 2 is a negative 16. So now we have to ask ourselves, is this a less than, or is this now a greater than? And we should all be saying that negative 8 is greater than a negative 16. So, moral of the story, if we look right here, we multiply both sides by a negative. If we multiply both sides by a negative, you must switch the inequality symbol. So we went from a less than to a greater than symbol. So we have to remember that when we're solving inequalities. Okay. Next thing, if we switch to division. So we start with the true inequality, which is 12 is greater than a 6. If you divide both sides by a 3, you would now have 4 is greater than a 2. Still a true inequality. So if we divide by a positive, we don't have to worry about anything. Now, if we start again with our true inequality, and we divide by negatives this time, let's say a negative 2. I would get a negative 6 over here, I'd get a negative 3 over here. And again, if we think about these two numbers, we'd have to say that negative 6 is less than a negative 3. So once again, if you divide by a negative 2 on both sides, you must switch the inequality. So moral of the story, if you multiply or divide by a negative on both sides, you must switch your inequality symbol. So with that in mind, let's take a look at how we solve using multiplication and division. Very similar to how we did it with adding, subtracting. So if I were to take a look at this first inequality, 4x is less than or equal to 12, I would simply divide by the 4 on both sides, and you would have x is now less than or equal to 3. Did I need to switch the inequality? No, I did not, because I did not divide by a negative. Okay, now if I wanted to graph that, once again, just a quick review, I'd have 3 numbers on my number line. I'd have a 2, a 3, a 4. I would have a closed circle at the 3, and I'd point my arrow to the left. Okay, next one. On this one, to solve this one, I would divide both sides by a 2. Not a negative 2, though. Okay, a little correction here. Divide by 2, and I would get a negative 6 is less than or equal to an x. Now, once again, a little review for our number lines. I've got a negative 7, a negative 6, a negative 5. This one, once again, it would be a closed circle. And now I have to ask myself, which way would I point my arrow? If I put one of these numbers in, for instance, if I put a negative 5 back into my inequality, a negative 6, is that less than or equal to negative 5? And the answer would be yes. So I'd point my arrow that way. Okay, and the last one here on this page. If I have a 32 is greater than or equal to a negative 6x, I would divide both sides by a negative 6. So 32 divided by negative 6 is 5 and 2/6, or negative 5 and 2/6, which is negative 5 and 1/3. Okay, and I get an x on this side. And for this one, since I did divide by both sides by a negative, I would have to switch my inequality symbol. Okay, hope that makes sense to us. Okay, now two more here. If I had these two now, I have m divided by 3 is less than or equal to a negative 6. To solve this one, I would simply times by a 3 on both sides, and I would get, these would cancel out, I'd be left with m is less than or equal to a negative 18. Did I need to switch the inequality? The answer would be no, because I did not divide or multiply by a negative on both sides. Here I multiplied by a positive 3 and a positive 3. So both sides I was multiplying by a positive 3, so I did not need to switch the inequality symbol. Okay, if I were to graph it, negative 19, negative 18, negative 17, I would in this case have a closed circle once again, since we have the equal to with it, and my arrow would point that way, to the left. Okay, next one. I have a negative. X divided by 5 is less than or equal to a 9. For this one, to solve for this one, I would multiply both sides by a negative 5. So if I multiply both sides by a negative 5, I would get a positive x. And on the other side, I'd get a negative 45. Do I need to switch the inequality? And you should have said yes. So we switch the inequality. It becomes greater than or equal to a negative 45. Number line for that one, I'd simply put three numbers on here, negative 46, negative 45, negative 44. And for this one, we would have a closed circle, and I'd have an arrow to the right. Okay, very good. So what I'd like you to do, you guys take a little time, solve these four inequalities, see if you can match them with the correct graph. So you should pause the video, solve these equations or inequalities, try and match them with the graph, and we'll come back and see what you do. Okay, you should have paused the video and did that. So on the first one, we should minus 2 from both sides, and you should get x is greater than a negative 3. So which one shows that x is greater than a negative 3? Well, since there's no equal to, I know it's an open circle, so it's either B or D. And since it's a negative 3, I'd have to go with letter D. Okay. Number 2, it says a negative x over 3 is less than a negative 1. So for this one, I would multiply both sides by a negative 1, or excuse me, a negative 3. And on the left-hand side, I get an x. On the right-hand side, I get a positive 3. Since I multiply both sides by a negative, I would have to switch my inequality. So I should have x is greater than 3. So greater than 3, we should have an open circle at 3, arrow to the right. So that would be letter B. Okay. Number 3. To solve this one, you should have added 4 to both sides, and you would have x is less than or equal to a positive 3. So less than or equal to a positive 3, closed circle on the 3, arrow to the right, which would be letter A. And for the last one, you should have divided both sides by a negative 3, and you would have x is less than or equal to a negative 3. And why did we switch the inequality? That's because we divided both sides by a negative. So if you divide both sides by a negative, you get x is less than or equal to negative 3, which would be letter C. Okay, one last slide, I believe. Okay, error analysis. Describe and correct the error in the solution. So pause the video, take a look, see what you find for an error. Okay, so if you pause the video and took a look, you should have seen that in the second line, they multiply both sides by a negative 5. So we're multiplying both sides by a negative 5. And we know that if we multiply both sides by a negative, that we should switch the inequality. So the error, they didn't switch the inequality. So the last line simply should have read n is less than a negative 10. Okay, that's a wrap. You can pause the video or stop the video and stop listening.